Hey there, are you ready for video number 3? Here we go. This time the question is asking us, when is this function here concave up? Well, that function is concave up. As soon as you see the word concave, you're talking about y double prime. Okay? Y double prime will tell you when a graph is concave up or down, but it'll also tell you if you're near a point of inflection. So those are the keys to um, remembering all these, what the three different y prime, and y double prime represent. Now, because this one is a concavity question, we're going to need to do derivative, so hopefully it's not too bad. Let's do the first derivative. The 5 goes away. Watch out for that. A lot of you messed that up on the previous test. Negative 6x plus 8x cubed. Don't bother doing anything with that. Do the second derivative. Negative 6 plus 24x squared. And what I'm going to do here, since y double prime is the thing we want, right? I'm going to common factor out a negative 6. And I think you get 1 minus 4x squared. I'm not going to lie, I didn't mean for it to turn out this nice, but it actually does turn out quite nice. And notice this time there's no denominator, so we don't have to worry about any undefines in this case. So y double prime equals 0. Some of you could probably see by looking at it, but let's pretend we're not very smart. It's going to equal 0 when that part is equal to 0. So 1 equals 4x squared equals a quarter, and x equals plus or minus root a quarter, which hopefully you all know is 1/2. So those are our 2 points. And what I'm going to do here, just to show you and demonstrate how to be a good student, I'd show the teacher that you considered that y double prime is never undefined. Okay? Mark that in there, communicate with the teacher, so that I know that you've checked it. There are some cases where it's not obvious that you've checked it, and you don't want to lose a mark because you didn't consider it. Now, some teachers would be really nasty and actually make you say why it's never undefined. And that's because it's a nice polynomial function. And polynomial functions don't ever have issues. Those were the good old days before we hit rational functions and trig and logs and all that. Anyway, so it's never undefined. So that's a good thing. So that means when we make our chart, we only need to include y double prime. And the only 2 points that are important are negative a half and positive a half. So we put in our zeros. And now there's only 3 intervals to check. Now, just be a little bit careful here. There's a bunch of negatives playing around here, but let's just pick one. Let's pick a number way out here at bigger than a half. So let's say 100. So we put 100 in here. It's 1 minus 4 times 100 squared. So 1 minus a giant negative here. So that's going to be negative times a negative, which is positive. Okay. Now I can tell you these signs are going to go plus, minus, plus. Okay, and how did I know that? Well, if you look up here, this 24x squared, that's the quadratic term. That means we have a parabola opening up, which is going to be positive, then negative, then positive. Okay, think of a parabola opening up. So positive, then negative, then positive, positive, negative, positive. So you could look at this and just use logic to do it. You could sub numbers into every interval here, but for example, I'm going to pick 0. If you put 0 in here, you get negative 6 plus 0, which is definitely negative. So this middle part is negative. Similarly, pick a number like negative 100. And I noticed that looking here actually doesn't help me in this case. If I put in a negative 100, that's 10,000 positive, because you squared it, times 24, that's a huge positive, minus 6. So this is positive. Okay? So we remind ourselves what this question is asking. It's concave up. So concave up means up like a cup. That means y double prime is greater than 0. The rate of change of the slope of the tangent is greater than 0. So y double prime is greater than 0. And you notice if you drew tangents, the slopes would get bigger as you went to the right. Your slopes would increase. But it's concave up like a cup. You can kind of see it. Now, keeping in mind, this picture here was the picture of y double prime. The actual function doesn't look like that. So I'm going to erase that just because I wanted to use it as a in-between tool. So when is this thing concave up? Well, I really don't like this color blue, so we're going to use yellow. concave up there and there. And don't worry if you're not quite following that graphical thing, we'll revisit that in a sec. So in other words, we're looking for, i.e., x is less than negative a half, or x is greater than positive a half. Those are the two sections where you're concave up. And once again, like I did before, you could say negative infinity up to negative a half in union with 1/2 up to infinity positive. If you want, you know me, I prefer this method, but either one works. You'll probably see them both in university. So that's that. So one thing I did want to make a point here about, if you think about this, this is a quartic graph. So a quartic graph that's concave up must have gone something like this. Concave up, then concave down like a frown, then concave up again. And it makes sense that I was concave up at this end and this end, but concave down there, which is consistent with a quartic that's opening upwards, like 2x to the fourth. Okay, so watch out. Sometimes you get like the whoop-de-whoops are not as clear. I call that curvilicious, and sometimes it's a very boring graph. There's not very much going on. So just be careful when you do your chart. One last thing I wanted to show you here, just because we've just learned how to do graph analysis. In here, your concavity went from positive to 0 to negative. And here we went from negative to 0 to positive. Those are both called points of inflection. Another question I could have asked you, which is on your sample test and on other sheets, where are the points of inflection of this function? The work would be exactly the same as all this, except at the end you would say the points of inflection are at negative a half and a half. And please make sure you realize you can't just find these numbers and state it. You need to see that the concavity switched from positive to negative and from negative to positive. It was concave up, then concave down like a frown, then it switched to concave up again. Without this chart, you're not getting all the marks. And I know that's what you care about. So there you go. Anyways, I hope that helps, and we'll talk to you soon.